One of the coolest things we've discovered recently is the existence of liquid saltwater oceans on moons of the outer planets in our solar system. Specifically, Europa, which is a moon of Jupiter, and Enceladus, which is a moon of Saturn. These planets are really far out, which means their moons are even farther. It's really cold out there, so how do they have liquid water on their surfaces? Well, we think that it's tidal heating. This is similar to why we have tides on Earth. So as the Earth orbits underneath the moon, the gravity of the moon pulls a little bit more strongly at this side of the Earth, which stretches the whole Earth out in a slow, silly putty kind of way and makes a football shape that rotates. On Earth, most of that deformation is absorbed by the water, but some of the deformation is taken up by the rocks, and that causes a little bit of friction and heat. At Earth, that's not a lot in our whole energy balance because we've got a lot of other sources of heat, but way out in the outer planets, that can be a significant amount of heat. So we think that these two moons are pulled by their giant planets, stretched like silly putty, and that heat keeps some of the ice from refreezing. So they have a liquid water ocean underneath the ice shell. But I said saltwater ocean, right? How do we know that? We haven't been swimming on Europa. Well, so when the Galileo probe flew through the Jupiter system, it took magnetometer readings. And when it flew by Europa, it saw these weird deformations of the magnetic field lines. Not like a big ball of rock was just flying through the magnetic field, but like there was a mini magnetosphere flying through. We know that Europa doesn't have a solid iron core like we do at Earth to create the magnetic field. So where on Earth is this magnetic field coming from? Well, turns out when you fly a conductive saltwater ocean through a magnetic field, it induces a current in that conductor. And when that conductor stretches all the way over the whole moon, it creates its own little magnetic field. It's the principle of inductance. So through these wacky magnetometer readings, we were able to determine that 1, Europa had a global liquid water ocean, and 2, that it had a salty water ocean. And where there's salt and water, there's a high chance for there being life. And that's why Europa and Enceladus are two of the best places to look for extraterrestrial life beyond Mars.